Yeah, so today we'll start with some of the tools we've not looked at. For example, we've not touched upon these tools. But if you remember, during the last lecture, we have touched upon some of these, which are surface edit tools. They are more or less similar in that for the surfaces we use filleting, chamfering, extend, and blend and match and merge, I guess. So the similar tools are even there for curve tools. So let's explore them one by one, and then we can go to a point. I'll try to cover most of the popular tools, and I would request you to try out the other remaining tools by yourself by going to YouTube or something. Yeah. So let's begin with the simplest tool here. That is a fillet tool, for which we require like two curves. So let's draw two curves first. We can use polylines. 1, 2, enter. 1, 2, enter. You can have some curves as well. We can have something like rectangles as well. What else can we have? Okay, let's try with these three examples. So let's execute fillet command, and all you need to actually do is just follow up on what is being asked in the command prompt. So it's asking you for the curves. So essentially filleting will require two curves, two lines, right? You have learned this in AutoCAD in second year, I guess, right? How to fillet things, how to trim. So it works very similar. Only here you have an additional option of, saying trimming as, join as. What is that, do you think? For example, let's do a fillet first and see how it works. So select the first curve. It's asking me the radius. At the moment it's 0, so let's see what happens. So because it was 0, you don't have any curve, but it has kind of filled in the gap and joined it even. Now why it must have joined it is because while we were doing this command, that this join equal to s is checked, right? So if I say again, also trim equal to s is checked here. So if I say trim equal to no, and then of course we need to put some radius. So what do you think could be the radius here? It could be anything, but the clue that you have is on the screen. If you look at these units here, each of this grid is 10 by 10 and the smaller ones is 1 unit. So whichever unit you all are working in, whether it's millimeters, meters, centimeters, yeah, one single unit would be always 1 unit. So if it is in meters, it will be 1 meter. If it is in centimeters, 1 centimeter. This would be 10 centimeters. All right. So let's give it some radius. We can give it a radius of say about 10. And if you can notice here, we have said trim equal to no, join is equal to s, and we'll select the curve and see what has happened. Why do you think this has happened? So first curve and second curve. Who can tell me why is this happening? Because we've given radius as 10, right? We thought we want to put a curve here, which is roughly, this would be a diameter, right? This would be 10 meters diameter. So our radius will have to be much smaller than that if the curve has to come between these two lines at this point. If it is more, then definitely it would exceed these, right? It would come there. So let's do it again. Let's go for a smaller radius, pretty small radius of say 4. And we'll say trim equal to no, enter. First curve, sorry, we have to change the radius also. 4, enter. Second curve. So now it has made a curve of 8 meters diameter. Are you following this? And it has not trimmed away the edges. If you can see, it has not trimmed away the edges. Why? Let's do it again. Now we would say trim equal to s, join equal to no, and radius will keep to same. So 1, 2. So it has now trimmed away these remainder portions of these lines, and it has not joined it, right? So if we say again, if you want to execute the same command again, just right click. So radius we would keep same, and we would say join S trim S, and now it becomes one element. Is this clear? Coming to this example, we can again say fillet, and we can reduce it to maybe 2 this time. Enter, and just say space bar. Space bar again would continue the command again. So 1, 2. Fine. Just clear. You want to chamfer, you want to have a fillet here as well. It won't work by itself because this is one object, so you need to first explode this. Select this, explode, and then execute your fillet command. Alright. Now we'll do chamfer. Let's see how chamfer is different than this. So go to chamfer. Now what is this distance? This distance again is going to be the distance between here and here. So if I click on distance, now 1, 1 would not create any chamfer. So let's try that out. First curve, second curve. It has created, but it has extended it and created it ahead, right? And it has joined it also. No, we had not checked the join and trim option on. So again execute. You can right click here and say chamfer curves. We can increase the distance. First chamfer distance to say 3, enter. Second chamfer distance to say 3 again, and join equal to S, trim equal to S. First curve, second curve. Now when you say, when the distances of the chamfer are similar, you would have an equal chamfer. Equal as in the angles would be same. Yeah. But if I say, for example, if I say unequal ones, so the first distance is 3 meters, I'll say enter. So whatever is there in the bracket is like by default, and if you want to type in a different value here, you can type in a different value here. So now it's 3 and 6, fine. Now you'll get a unequal kind of a chamfer. Are you following it? So it takes the distance from the first point, distance from the second point. So here it was 3 meters, here it was 6 meters, fine. And it has made it into one single element. Now again come here, you will keep that same and just keep clicking. Now, this you need to explode, and we can make it equal again, 5 and 5. Okay, so that's about filter and chamfer. Let's come to the next one, fillet corners. So for example, if you have a rectangle, this is going to be similar to fillet, but I guess it would do it all at once, and probably it will work on a primitive like this. So say fillet radius of, yes, so it works all at once on the object. You don't have to even explode it, and it can be one single object like this, right? Coming to the next one, we'll use the blend curves. So we can draw some lines here. I have right clicked on this one so that I can draw lines, because I don't want polylines, I don't want continuous lines, so I use lines. So we have these two lines, and we need to create some blend. We'll draw also some curved lines. Okay, and we'll try to blend these two. So let's see how it works. Blend. There's also a quick blend tool which I'm not finding here. Probably it will be there under here. Okay, it's a quick curve blend. See what happens here. It's asking you for the first, second, and it's created a blend. Fine. We'll do it again. So the kind of curvature that you get here is determined by the continuity setting here. So you can change it to anything. You can change it to say curvature. You'll get a much more smoother curve than the earlier one. Slightly, there's not much change, but generally it is more curvaceous than the tangency. So just say undo and do it again. So what is this? Perpendicular curvature. Fine. So we'll use curvature here. First curve. No, one second. First curve and the second curve. Fine. So it's tried to blend it. Second curve, so if you want to blend these two, so quick curve is not available on this palette. So you'll have to go under curve, blend curves, quick curve, select this one, select that one. So it will automatically put a line in between. Is this clear? But you can't adjust the parameters of this. Fine. There are other tools which I'll show you for blend, where you can adjust its settings. You can make it, you can kind of custom create or custom shape it. So let's see how it works. Go to curve, blend curves, adjustable curve band, 1, 2. Then you get these. So now what you can do is, if you're not happy with this curvature, you can move this point like this. Fine, you can move these points like this. And then you can hold on these buttons. One second. See, you can adjust it like this. Yeah, you can click hold on to these handles and you can further shape it the way you want it. Are you following this? You can move it ahead also. You can shape it like so. So these settings are there, and plus moreover you can try using different other types of curvature techniques. So generally tangency will have limited such points. You have only 2 points for adjusting. One is to move like that, and the other point is to adjust the curvature. But if you go to curvature, then there are 3 points. So then you can move these and then use these handles and adjust its curvature. You need to practice to know how it works. And then G3, G4 will again increase the number of points here. So you can have still little bit more controls, for the curvature. This is only for advanced users, once you know how to work with curves. So generally tangency and curvatures, these are the best options one can go with. And what you would want to say is trim and join. So when you say trim and join, these extra portions of the earlier lines will be trimmed away, and this member will be joined to the earlier 2 members, and it will become one curve. See, is this clear? So this is adjustable curve band. What else do we have? Arc blend. Okay, so just delete, undo this. Let's see how arc band works. First curve and second curve. So it just draws an arc between the 2, and then you can adjust its. This is more like an arc, so you won't be able to adjust the curve as much as the Bezier spline that we had for the earlier adjustable blend tool. So this is more like an arc, okay, which is this. Fine. And we'll look at one more, which is match curve. So let's just delete this. Come to match curve. select the first, select the second, and see this one is completely different than the adjustable blend. What did the adjustable blend tool do? It just tried to fill in these two gaps actually, right? And you can say okay, but we further adjusted it. So it's up to you whether you want to adjust the length of these earlier curves or not. But generally it fits in into this gap. But here it doesn't. Here it changes. It almost merges the two, so that they are much more smoother than the earlier curves. So it changes the geometry of that, right? And that can further be controlled by this. How much curvature you want, or you want that to be you want that element to be tangent to the first and the second one, so then accordingly it will kind of merge it. And you can say average curves. If you remove average curves, then what happens is the second element will remain, second curve will remain as it is, and the first one gets deformed. And if I select these element first while executing the command, if I select this is the first curve and this is the second curve, this one will remain, this one will change and this one will remain as it is. I'll show you in a while how it works. But essentially tangency would be an option, and if you remove average curves, then what you will get is you may want to retain one of this. If you want to average out both the curves, you can say average and tangency. If you say average and curvature, you will get altogether different curvature. So average and tangency generally works fine, and then you say okay, then this becomes one curve. Fine. Now I'll do the same thing again, match curve, but this time I'll select this as the first curve and this as the second curve, right? And if I remove average, see now what has happened. This one has remained fixed and the first one has changed. But if I say average, then both gets changed. And tangency option allows you to be closer to the original curvatures, and if you click on curvatures, you'll get much more smoother curve, but then it will go out of the alignment of the earlier curves. Fine? Clear? So you can try these out yourself. What would happen to position? If you say position, then what it will try to do is it will just bluntly take these points. It will not try to average it out. It will just try to fill it in, and it would be more or less like a straight line. It won't have a curvature which is tangential to the earlier curves, right? So generally go for these two settings here, and you can leave the other one as is, right? Or if you change the other one also to tangency, what happens? Let's see. Nothing much happens. Slightly it changes. Yeah. Slightly it changes. Right? Okay, next up, we'll delete these. We will look at how the extend tool works, which is here. Now if you look, there are some more tools hidden under extend. So we look at these. How do they work differently? Just draw a couple of lines here with some curved lines. Okay, so let's see what the first tool does. Extend curve. It will ask you for the boundary object to which you want to extend the line. Okay, so for example here, if I click on this one, so that's the boundary object, and if I want to extend this, then I would say enter. You can select more than two boundary edges. So if I want to do all these operations at once, extend here, extend here, extend here, then I can select both these boundaries and then say enter, and curve to extend. Now if I click on this side, this end will extend. If I click on this side, this end will extend. Fine. So it depends where you want to extend it. You can extend it one by one, no problem. And this has extended as a curve, right? Fine. Is this clear? Well, I'll do it again. So extend. You need to have the boundary edge. Extend. Now you can't extend this one because you've not selected this boundary edge, so we can select this boundary edge and then select these curves. Clear? Now what happens if you have a curved object like this and you want to extend these? Fine. So if you say extend, see I have not selected any boundary edge, but I can say enter and curve to extend. So I don't want to extend it to any boundary, right? So then you can just press enter, and then this can be, just pulled up like this, or you can give an extrusion vector here. So if you want to extend this by say 10 meters, say enter 10. Has it extended? I don't think so. Or you can say 30. So what happens is if you press 20, 30 here, the inputs, then it goes straight. Fine. But if you want to extend it like this, sorry, 1 second. Extend. So I don't want any boundary edge. Say enter. And if you want a curved extension like this, then you don't put in any input values here. But if you want a linear extension like this, so from this point it will be tangent, then you can press any value, say 20, and it would go straight. Is this clear? Okay. So similarly I can do it for this also. I can take it straight even. Okay. See here what happens. Why does it extend to complete the circle? It doesn't go in any other direction. Why? Because this is an arc. I drew an arc here. Right? So that is an advantage of Bezier splines. These are Bezier splines where you can extend it in any direction. Is this clear? Is this clear? Okay, next we will look at some other things. Extend curve, smooth. Extend by line. Extend by arc. Extend by arc. Extend by arc again. Okay, fine. So let's look at these. How are these different? So extend curve, smooth. So if we say this, so I guess this is much smoother than the earlier option, and it doesn't ask you for a boundary edge, right? See? It's little smoother than the last command. Use it over this. Yeah, if you over this one, use it over arc, again you can control its curvature. It's no longer restricted to arc. Did you see this? So it's a nice option. More or less they work in the same manner. Now extend by line. So if I click on this one, it extends only a line from there, right? So if you take a curvature like this, it would be extended only as a line. Is this clear? So you can try out these different options by yourself. Sorry, what is this? Extend curve on surface. So let's see how it works. We can draw some surface. And we'll execute that. Extend curve by surface. Extend curves to extend. Enter. Surface that curve is on. Select surface that curve is on. So let's do it slightly differently. Let's draw a sphere. and we'll draw curve on the surface. So let's say curve from object. No, we have an option here to draw on surface. So where is it? Interpolate on surface. So we can draw some curves like this. Okay, so we have some curves here on the surface. Fine. And then what we'll try to do is we'll try to use this option, select curves to extend, enter. Select surface that curve is on is here. So it got extended. Got this? I'll show you again. I have drawn on top of the surface by using this tool, interpolate on surface, which we have covered earlier. And once this is drawn, then we can use this tool, select surface that, you have to first select the curve, enter, and then select the surface that the curve is on. So curve will get extended automatically. Fine. And then you can do various things here. You want to array an object like how we had done earlier. The last lecture we had just arrayed spheres along this curve and all that. So that can be done. Fine. Okay, next we'll try to use these commands which we've covered already before, trim, split, but I'll just show you since we have some lines here, just show you how to use them. Maybe I'll draw some more lines like this. Just see how these works. So this is a straight line, for example. So if I say split command and objects to split, so this is the object that I want to split into pieces. So say enter when done, and cutting object. So this is the cutting object and I want this as the cutting object, I want this as the cutting object. Say enter, and if you look at this, these are all smaller pieces, right? Fine. Similarly, if I want to cut this one, then I can go with the same command and select the object to split. Say enter, cutting objects 1, 2, 3, enter. These are not cut. Why? Because these are not connected to this. So what you would need to do first is extend the lines, select the boundary edge, enter, extend these lines like this, and then you can split, use the object that you want to split, enter, use the cutting objects, enter. See this? Fine. Clear? Similarly, you can do it here and here as well. Let's see how trim is different than this. We'll undo couple of times. So we'll try to use trim now. Say trim cutting objects. So during the trim operation, it asks you for the cutting object first. So select the cutting objects. Fine. Say enter, and then object to trim. You can just trim it. Keep trimming it like this. See, for a trim object, the extension works. You don't have to extend it and all. So otherwise what I can do is execute trim command and select all of this. Say enter. All of these is cutting objects. Enter, and the objects to trim. So we can just trim away things like that. Yeah. Fine. Is this clear? So that's about split and trim. Since I'm showing you split, I'll also show you how trim works with surfaces. So for example, if I have a sphere drawn here, and if I want to cut this sphere into pieces, then I can draw a line, left click, I can draw a line like this. We've done this before, and we can just simply say trim, select this as the cutting edge and this as the, so it gets trimmed away. Fine. But let's say I want to retain both the pieces here intact. The trim command removes the other part, right? So you want to retain both the parts, then you need to say split surface by iso curve. Sorry, split. Use this objects to split, which is this, and cutting objects. Enter. Now these are into two pieces. Are you getting this? See this? Alternately, what you can also use is cutting planes. So you don't want to use by line. We'll do undo. So the other way, you need to decide which method you should adopt to split. So this is one method what I've shown you just now. I'll show you another method, which is to create a cutting plane by going under surface plane, cutting plane, object for cut plane. So we have to select the object and say enter, and start of cut plane. So we can start, we can, in any manner we can do this, but if you go to the and say enter, if you go to the perspective view, it has created a plane like this, right? And you can rotate this plane, you can do whatever with it by putting your gumball on. You can rotate it, yeah, move it, and then you need to execute this command, same command, split object to split, enter, cutting object is your cutting plane, enter. So you got a line here, which is an indicator that it has been cut into two halves. Is this clear? So since I'm showing you split, I'll show you one more method of cutting this. Now with this cutting plane and with the other method of using line and using split, you will generally get an open surface like this inside, hollow. But sometimes after cutting you want to have a solid. And how do you do it? So there is a tool here which we have not covered before. It's called as Boolean split. So first we need to undo it so that it's a full sphere, and then say Boolean split. So it will ask you to select the surface to split, enter, cutting surface to split, enter. Now if you see, this is a solid, right? So you know when to use trim command, when to use split command, and when to use surface plane, cutting plane, and then how to use your Boolean splits. Is this clear? Okay, so we'll begin from here again. So wherever we were, let's do undo a couple of times so that we can go back to where we were. The top view. So okay, we'll do something else next. So let's assume you want to draw some shape, and you know what the shape should look like in your top view, and you want to look, you want to have a particular look for the curve even in your front view. So for example, if I draw some curvature here, I start something in the top plane, and then I go in the front view, right? And then I can come to this view and I can draw some interesting curves. I can continue working in plan, and then again come back in this viewport, right? And if I look at this curve, it's quite a very interesting curve, right? And if I pipe this, it's a very interesting curvature, right? How did I draw that? I started drawing it in plan, and then I moved my cursor here in the elevation view, and then I moved it here in this, right? And The advantage of using this curve is it will not give you kinks or it will not give you corners. It will smoothen out all the bends and everything. So that's a good thing. Fine. Is this clear? But what if, let's say, I want this curve to look like an S or an M or a Q or a R, whatever, and then in the front elevation I want it to be seen as a V. So in the top view you want that to look like an S, in the side view you want to make it look like an M. So can you wrap this entire curve? So the curve will still be wrapped like that, but if you see it from the top view, from the aeroplane, you will get to see it as a S or M, and from the sides you will get to see it as something else. Fine. So this is a very, very interesting command, and this is one of my favorites as well, so you might want to pay attention how to do that. Okay, so let's draw some curve here. So for example, let me just draw an M here. You all don't do anything, just follow up. I can put the control points on and I can move it like this, right? And then what I can do is I can take this control point, maybe these 3 control points in the elevation. Maybe I'll move this one slightly like this. So now what I can do is I can take these points and move them on top using gumball, and then I can take these 2 down, right? And I can make it look like an M, right? It looks like an M in elevation as well and in the top view as well, right? If I go to the perspective view, it is again it is not a 2-dimensional thing, right? See, so it's an M from top and it's an M from sides, but you can't be very precise with this. Fine. And let's say sometimes you have curves like this, so it's easier here because it has got very few control points, very few control points, so you can tweak these like these, right? But let's assume you have a curvature where you have a lot of such points. So for example, you have a curve which is highly bent and highly curvaceous like this, right, which can't be drawn by a few points. And then you have this, and let's say I want to make it similar to, I want to make it look like M now. Is it possible? I'll have to move all these points one by one. So for example, I'll move all these points. So I've selected it in plan and I can move it in the elevation, right? And then I can take maybe a few of these and then take it down. So it's possible, but sometimes it can be very difficult because you might have to move each and every point and you may not get desired results and all the things. You're getting it? So this is an M here and this is a different shape here. Fine. So if I go to perspective, escape twice, and you can get an M shape here, but it's not precise and you might have to troubleshoot a lot of things and spend a lot of time doing it. I'll show you an easier method to do this. So let's draw this again and let's draw an S. Let's draw a nice smooth S. Okay, enter. Okay. So we have so many points here and I don't want to select these points and then drag them in the elevation, but instead I want to draw another, but I should know the limits of this. How this technique works is you should know the limits. So these are the limits of the first curve, right? The second curve that you're going to draw that needs to resemble the shape in the elevation has to be within these constraints, for which I'll use one of the OSNAP buttons. You all are accustomed to how OSNAP works in AutoCAD, right? And perpendicular, midpoint, all this you are aware of, right? So we will put OSNAP on and we will put Smart Track on. I'll just tell you in a while what is Smart Track. So we'll start drawing it in the front elevation. We'll draw something like an M. So we can start from, say, from here, and we need to end somewhere here. So what is Smart Track? Now if I hover my mouse over this point and move it on top, see what happens? You get a line here. So that is called as a smart rect. So it will try to reference the last point and try to create an imaginary line, reference line, so that you can draw exactly along that, and say right click, enter. And what I'll do is, in fact, I'll move this point also on top. So we have this shape, and these are aligned, more or less these are aligned, fine. This is the lower line on the top floor, and this is what I drew just now. But the problem with this is it's not exactly a vertical line. See, I don't know what happened here. Okay, when I drew this point, it was snapped. It was snapped to the end of this line. So that's how, you know, it did not remain as a straight line. Are you getting it? Yeah. So, but there is a way for it. So sometimes you might be, you know, kind of, you know, settled in drawing all these points, but you don't know that you have snapped it to other points and stuff. But there is a way around here. So what you can simply do is select that point. But before that, I'll just execute the command and show you whether it works or not. So here it looks like an M, and here it looks like an S. So let's just use a command called as curve. Curve from two views. First curve and second curve. It's not necessary you have to select these curves in different viewports. You can select it in the same viewport also. So that is, you can select it in the perspective view also. And then just say. Now it doesn't work because it gives you some other settings here. Curve extrusion direction, and it will not work. See, it has not worked. It has not created. It has not joined these, right? It has not created any third curve, has it? No. So why is this not working is because of this curve. Because see, this curve is exactly on the ground, whereas this one is not. Because we had kind of, you know, drawn it in reference to one of these points on this curve. So the workaround for this is like this. You just select this curve and go to transform, go to set XYZ coordinates, and what this one does is it can align all the points on this curve based on which axis you want to align it with. Now which axis do you want to align it with? With this axis, right? Which is what? X axis, but it is perpendicular to what? Y. So we want to align it perpendicular to Y, right? So then we would uncheck this and we would just keep set Y, fine, and we would say OK. So now it is aligned all the points. It's the same curve, but it has aligned all the points. Now you can say, where do you want to move this line? So I can say I want to move it somewhere here, and click. So now this is exactly perpendicular. So now this command will work. You go to curve from two views, 1, 2, and you got a third curve now. If you look at the third curve, so I'll just hide these two. So the third curve, 1 second. Yeah. So these were the earlier two curves. And this is the third curve. So if you look at this from top view, it is still a S, and if you see it from the front view, it's an M. If you see it in the perspective, it's like this. Is this clear? So let's unhide all the curves. So these were our original curves, and it merged and it created this one. Okay. But the problem that could occur here is, let's say for example, this curve is slightly more than, just extend these points. There's a lot of points on this. Now I'm selecting a wrong curve, so I want to hide this. These are original points. So I want to extend this slightly here. So in this case, I'm trying to show you that if the curves are not aligned, so this curve is bigger than this one, right? If you look at this one is bigger than this, is it not? If this one goes beyond this, and if you execute that command, what would happen? So if you say curve from two views, 1, 2, it has created it, but it has trimmed it away. If you can look at it very carefully, if I click on this, there are two curves. See in the perspective view, this was our original one on the ground, this is the new one. So what has happened is it has trimmed away that part automatically. Are you getting this? So you might get, you might want a shape like this, but you won't get, it gets trimmed away. It aligns it with the first object. Right? But there is a workaround. Let's say, for example, you want to align this curve with this extents, right? So you have these extents from here to here, and you want to align this to this extent. So there's a command called as align profiles. So then it'll ask you select curve to align to. So I want the second curve to align to. Select curve to change. So we'll have to select the first one. Select curve to align to. This is the one, and we want the curve to change is this one. So now if you look at this is changed. Are you getting it? Which one did I choose? I chose the wrong one. So just a minute. So this needs to be hidden, and we have these two. So this one is longer than this. Yeah. So right click, align profiles, curve to align to, curve to change. So this curve got changed, and now you can execute that command, curve from two views. Is this clear? So this is a very, very interesting tool you might want to practice. Okay, next up a similar tool, but this time we'll create one first tool, first curve, and we'll have an end curve, and we'll create transformations between this. So we'll say curve, twin curves, select the first curve, start curve and end curves, and number of transformation curves you can say 10 or 5, I think 7, enter. That's about it. So it has created all the transformation curves between them, and then what I can do is I can take all of these and I can just say a loft, and I can loft it. So fine, see, it doesn't make sense to loft them because they are all in same plane. So what you might want to do is you might want to move them maybe up and down. So take this up, maybe take this one down here, take this one up, take this one down. So then again you could select all of them and then say curve or surface loft. So now you'll get something different because you have now changed the curves up and down, right? Okay, next up, one more very important tool in curves. We have a couple of shapes here. We have circle, we have hexagon. So we have some shapes here, fine. And let's say we want to sort of create profiles from these, okay, looped profiles. For example, I want to create a loop polyline like this or a loop polyline of this shape, right? then it's very easy. You need to go under curve tools, Boolean, curve Boolean, or curve from objects. Where is it? Curve Boolean here. So then it would ask you to select the curves. You can select all the curves, right? Like this. It will ask you to delete the input. If you say S, for example, if you say all, then what it would do is, for example, then it would ask you to click inside the regions to keep. So I want to keep this region, for example, and I want to delete all of the other things. So then I can just click inside. See, a little highlight of gray has come. That means that only this portion will be retained, this profile will be created, a loop profile, and everything else will be deleted. Fine. So this is a looped profile. You don't have to even join and things or fillet things. It becomes as one object. So again we'll do that. Select, go to Boolean curve, and this time I don't want to delete anything, so I would say none. And then click inside the region. So I want to keep this region, I want to keep, say, this region, I want to keep this region, and okay, this region also, and say enter. So all those that are highlighted in gray would be retained back. So if you can see here, it has created separate objects from here. Are you getting it? There would be one which is here again. So this one was not there earlier, so it has created this. It has created these even. Alright? Are you following? Let's do it again, one last time. Boolean. Delete input all, none. Combine regions, no. See why it combined this region with this one earlier? Because this combined region was S. So now we are saying it no. So select the curves and enter. Click inside the regions 1, 2, 3, 4. These are the ones I want to keep now. Say enter. So if you can see, these are all different curves now. So when you select, when there are more than 2 objects under that, you would see a lot of these options. So you just have to hover your mouse and select the right one. Okay. So this is how Boolean curve works. But for example, let's say you want to have, so I'll draw one more square here. Or let's just do without the square if we can do. Select the curves. No, it will not work. So I can draw one more square, big square like this, and let's say I want to have these region now, the external region with these outline. And I can use that again. Can select all of these, enter, and just select the region. So I want only this portion. Then you can say enter. So I have got this and this curve. Which has not created, I guess. I don't know why. Let's do it again. Select input, yes, I'll say all. Combine regions, no. Select the curves. Press enter when done. Select inside. So I want to retain these. Enter. See, it has created the boundaries. So this is like your plinth of your building, right? And you can delete these now because you are interested in creating the plain outline of this. Fine. This is how it works. Okay, we'll move to surfaces now. We'll delete what we have on the screen and just draw a simple surface using 2 points. It's a longish surface like this. And if you put on the iso curves on, then you would see that, and if you put on the control points on, there are only 4 points. But let's say if you want to convert this into a very wavy kind of a surface, and what we have is just a planar surface, try moving these points, it won't become wavy, right? This is like a hyperbola I got, hyperbolic parabola. I can put my gumball on and I can move this one on. and I got almost like a hyperbolic parabola, right? 2 points up in the air. So still a curvature. But let's assume we want to have more control with this curvature. Fine, like we want to move things here also, because we don't have any points here, we can't do that. So let's put things on ground first, and the way you can increase the number of control points for this is by saying rebuild. So you just type rebuild, enter, select the surface, enter, and then you can say how many divisions you want in x direction, how many divisions in y direction. So the divisions along x direction are referred to as u, count, and divisions along y direction is called as v. Now these terms are very common in any 3D modeling softwares like 3ds Max, Maya. So they're basically divisions in horizontal and vertical directions on the surfaces. We can increase the number of count, but we'll restrict to 10. So we have increased the number of points from just 4 on the corners to so many. Now what we can do is we can click these and we can have much finer shapes, right? Like that, which was not possible earlier because the number of control points were much less. Is this clear? Fine. Okay. But we don't want to go in that area, so what we would do is we would just give it some sort of a curvature. So what I can do is I can maybe take some of these points, maybe just take some of these and take them on top. Second. Now in fact I'll revert back to my 4 points because I don't want really so many points, because I'm really not interested in this extravaganza, because what I'm going to show you next has nothing to do with this, but my intention was to show you how you can modify this curve as you want by using rebuild command and increasing the number of control points. But I would like to go back to 4 numbers only. So go to rebuild, surface, enter, and I would go with just 1 each. So still I have some curvatures, fine. So now what I can do is I can grab hold of these points and I can move it. What am I doing? On top, and maybe I want to move these also with these 3, like that. So I have some sort of a surface now, right? Fine. What I can do with this, so I can move this one slightly up above the construction plane. Now I can do a lot of things with this. For example, if I want to offset these, put off the gumball temporarily and go under surface tools. We've covered most of the others, fillet, merge, match, all that. We've not covered the offset surface. So we'll say offset surface, and then it'll ask you which direction do you want to offset this. So if you want to offset it below the surface, you can do, just click on the surface, and then you would be asked to give a distance. So I would put a distance of say 2 meters, 2 units on top. And do you want to make it solid or no? You don't want it as solid, you want it as open-ended. Then say solid equal to no and say enter. You'll get an open-ended curve, fine. But if you want to say solid, you can say solid equal to S. You can increase the distance slightly more, and that's about it. Just say enter, you will get a solid, fine. I think we briefly covered this during my last lecture, but I wanted to show you the next tool. So just say Ctrl Z again, and this time we will say, instead of saying offset surface, we'll say variable offset surface. In this case what happens is you can really determine the offsets need not be equal on all the 4 sides. You can say, like, on one end I want it higher, maybe on 2 opposite ends you want it to be higher, and other 2 ends you want it to be lower. So after saying that, you can put additional handles and all that, but let's not go into it. Side tangency, no, this doesn't apply. So leave everything as is and say enter. So what have you got? You got an offset, but you can get a variable offset where sometimes somewhere it can be higher, lower, smaller, bigger. The only disadvantage with this tool is you don't get a solid option with this, okay? But you can fill this up. Very simple. What you do is draw a line. You have to put your O snap on and put the endpoints on. So then you draw your line between these 2 points. And what you do, which command will you use to fill this? There is a profile here and there are 2 rails. So you will use a sweep 2 rails. So surface, sweep 2 rail, first rail, second rail, and the cross section. Enter. It got filled up. Don't change any of this because we've done this before. Say OK. And then you want to go to the next edge and do the same thing. You already have a line here. So you just say right click, first rail, second rail, section, enter. Okay. Again rotate. Enter, first rail, second rail, cross section, enter. And then this is the final step. First rail, second rail, and this time there are 2 cross sections. There is one here also, right? So we will use one, and you can have as many cross sections, but you can have only 2 rails, right? So you want to use a surface edge or you want to use an edge. So I'll use the one that I drew. And say enter. OK. So you could convert these into a solid. Now the only problem are with the colors. You might want to ask me why these colors are different. I've explained you before that all that is inside is displayed as green and the backside is displayed as white. Now you can flip this. You can individually flip this coming under this analyze direction, right? You can change it like this. But the easier way would be to combine all of this into one object by doing a union, and by default it will change all the colors by itself. But it is not, there is some problem where it's not getting connected, I guess somewhere. It's not getting joined. Now it's joined. Yeah. So I was using Boolean. Don't use Boolean because Boolean works only with solids. And what we had here were the surfaces. So for surfaces you use instead join. Right? So now you don't have to change individual colors. This has all become like one poly surface. If you go to property details, you will see here it's a valid poly surface. It's a solid poly surface with 6 surfaces. Now it's become like a solid. Is this clear? So I'll just show you one more tool before you go ahead and practice. Yeah. So if this is understood, I would keep it on the side anyways, and I would draw, let's say, a box here. And I'll show you one more tool, which is solid fillet. Now where is fillet? Fillet is here. So fillet, first surface, second surface, you got a fillet, right? Okay, so you can fillet it like this, one by one. So you can again come back here and select this surface, but there are problems here, right? The easier method would be, if you want to fillet all of this at once, what you can do is, you can pipe around this. So for example, if I execute a pipe command, and if I say chain edges, then I can just select these. So all of these lines are there joined as one loop, and then I can give it a diameter of say 1.5, enter. So it has piped it, right? Then what I need to do here is I need to use a Boolean Boolean split, or we can even use split. Let me use Boolean split and see. So Boolean split, surface or polysurface to split, this one, enter. Cutting edge is this pipe. So if I now delete the pipe, I can delete this and I got a, but I don't want to do this. In fact, I want to fillet this later. So I don't want a solid. So undo couple of times. You can explode it, of course. What you can do is you can explode it even. So right click on this to redo. Redo is not working. Let's do it again. So pipe, enter, chain edge. Now what chain edges do is it takes individual edges and chains them into one, so that you don't have to execute pipe command over each of these lines. You say enter and give it a radius. So 1.5 is the default. So enter, and then I'm using this one. Okay, let's use split command and see how it's different, because I don't really want it solid. So we'll say split, use this object to split and enter. Cutting object is this. So I guess it has cut it into two halves. There you have it. Yeah, the surface fillet. But first surface, the radius is 1. So let's increase the radius to 2. Enter. Yeah, so now it works. But I was trying to show you some other command, not this one. Solid fillet is there option under this. Yeah, fillet edge. Okay, under solid there is a fillet edge option. So if you want to do it all at once, then you just have to say chain edges and then select the chain of edges. You can then say enter and give it a radius. Now by default it is 1. Okay, and if you want to change it, what you can do is you can simply zoom into this and you can hold on to this, not this button, and then you can increase the radius like this. Yeah, and you can say set all, trim and join, yes, set all. We can even give a radius, like you can type in here, or if you want you can even manually change it for each one. So this is like a variable. What I was trying to show you is a variable offset. So in this case it is slightly bigger. Here it's 5. Here I'll make it maybe 4. Here I'll make it like 3. Fine, and enter. But sometimes it can give you some weirdness, but it serves the purpose. See, here the fillet has reduced from this end to this end, this end to this end. Fine, but sometimes it may not be the right result. You might want to blend this to edges and other things. Fine. Whereas over here I showed you two options. If you want to create a counter fillet, you can use that method, Boolean split, or if you just want to fillet it for individual surfaces, you can use this method. Fine. So either one works. So if we need to fill this up, you can also use blend surface tool. So blend surface, you use the first segment edge. You can say chain edges here again, which is, I don't know if it is there or what, but yeah, you can chain edges, I guess, like this. And then the second segment of edges, 1, 2, 3 and 4, and say enter, say preview. So it still does the work, right? And then you can change this curvatures as you want. You can make it tangent like this. You can even control it manually, you know how to control it, and say OK. Is this clear? Do you want me to show this again? 1 2 3 4, enter. Second edge 1 2 3 4, enter. There you have it. You can adjust the shape as you wish. Fine. Say OK. Fine. This time we'll use pipe to create variable fillet between the surfaces. So start radius and radius. So there are different radius, and then pipe this. And then what do? We use a split command, and with this select object to split. Select cutting edge is this, then just delete this and just delete these two things. So then we have this, right? Now we can use our blend surface command between this, and then use, this is what I was trying to show you, where you can have variable fillets. Is this clear? Right? You may want to practice this also.